This is going to be about probability, but using sets. So using sets, we're also going to be talking about some more complicated ideas of of probability, such as conditional probability, etc. I believe in this chapter. Yeah. So first of all, let's do a recap of how Venn diagrams work. Okay. I'm going to put the basic principles of Venn diagrams on the board first. Let's see. I assume you already know how a set works. A set is basically a collection of things, numbers normally, that's written like this basically, okay? It's a set of numbers basically. Uh, the number of elements in a given set is given by this notation, n of a, for example. In this case, n of a is 3 because there's 3 elements in the set. A universal set is the set that contains everything that is being discussed in a particular problem. For example, my universal set could be all the students in a classroom, and then a specific set in the universal set could be all the students who are taking math. Okay? So the universal set contains the whole classroom, basically, everybody that I'm considering. Okay? What is a subset? For example, if A is a set of things, B could be a subset if it's basically a part of A. Like for example, A is all positive numbers and B is all even numbers. Right? For example, in that case, B would be a subset of A because B has some of the parts of A. Is this like, do you know what this is?
Yeah.
Okay. Do you know how complement works? For example, what is the complement of a set? Hmm? What does it
Uh,
mean when I say A complement, for example?
isn't it everything that's in A?
No, that's A itself. A is everything in A. What is A complement?
I'm not sure.
So, for example, if you have a universal set, actually universal set is written by this kind of symbol. Let's say my universal set is 1, 2, 3, 4, 5, 6, and 7. And then I make a new set A out of that universal set which contains 2, 4, 6. What is A complement now? What is everything in A complement? Any idea? A
Um,
complement, this symbol means complement, and what A complement means is everything not in A. Okay?
okay.
So everything not in A. That's what A complement means. So, what are all the members of A complement?
Like 1, 3, 5, 7.
Exactly. So everything that is in the universal set, but it is not in A, is the complementary of A or complement of A. Okay? This is going to be
Okay.
very important, by the way. Make sure you understand this. Is there any confusion about this?
No.
Okay, good. Now, how does it look on a Venn diagram? For example, this is set A, right? Right?
Yeah.
So A complement will be everything outside of A, basically. Does that make sense?
Mm-hmm.
Okay. So now you know what complement means. Now, what else do we have? The intersection. What does it mean when I say A intersection B? Do you know what this means?
Numbers are both in A and B.
Exactly. And on a Venn diagram, it looks like the common part of A and B. Okay? So where they intersect, basically, that's why it's called the intersection. And what about union? Do you know what union means?
Um, all the numbers are both in A and B,
Exactly.
and in the intersection
Yeah,
too.
exactly. So basically, the sum of everything that is in A and in B. We don't care if they're intersecting, we don't care if it's in one of them, just everything in A or B. Okay? So, uh, there are some things that we need to know about already. Okay. Finding the probability of an event. We talked about basic probability in an earlier class. You know this, right? You know
Yeah,
what experimental probability is, you know what relative frequency is, you know what theoretical probability is, you know what those things are?
yeah.
Okay. Can you tell me how to calculate experimental probability? Like what would you need and how would you calculate it?
Um,
This is not good because like we've already gone over this stuff and if you don't know this then you're not going to understand much of this chapter. So experimental probability is when you do an experiment and you check, for example, when you flip a coin and you get heads 4 times out of 10, the experimental probability of getting heads is basically how many times you got heads divided by how many times you tried. So 4 over 10. Okay?
mhm.
What about theoretical probability? How do you calculate that? Do you remember?
Wasn't it like like I don't know how to explain. Um,
For example, when you toss a coin, how do you calculate the experimental probability of getting heads? Sorry, the
so
theoretical probability of getting heads.
like, doesn't it depend if it's like let's say if it was a dice, if it was like a fair dice,
Okay, a fair dice, okay. What's the theoretical probability of getting like a 2?
it would be like 1 out of 6.
Yes, and it's theoretical because we're basically looking at how many ways you can get a 2, which is 1, there's only one way, and divided by how many different things can happen, 6. So that's why we call this the theoretical probability, because you might not get a 2 only 1 out of 6 times, but it is what you should get. Okay, and finally, do you know how, like, read this statement? Calculating the probability of that something will not happen if I tell you the probability of that thing happening. For example, if I tell you that the probability of an event happening is 1 over 10, can you tell me what the probability of that thing not happening will be?
9/10.
Exactly, because you have to do 1 minus the probability of it happening. This is called complementary events. If two events are complementary, that means they're exact opposites of each other. They can like never happen together. That's not actually true. The opposite, basically, they're opposite events. Okay. So to find the probability of an opposite event, complement event, just do 1 minus the probability of that event itself. Okay. So these are all the things you're supposed to know from before. Now let's take a look at the kind of stuff we'll be learning in this chapter. So what we're gonna do is um, do a question where we're gonna set up a Venn diagram first. Just a second. In this question, we're gonna actually create a Venn diagram first. Okay. So which two circles should I have in my Venn diagram? What should the two circles correspond to?
Uh, um, prime numbers
So let's call it prime and
and
greater than 2
then
as a t. Okay.
okay.
So p means it's a prime number. T means it is more than or equal to 2. No, more than 2. Okay. So on a six-sided die, what should I put here? What should I put here? And what should I put here?
Um, put 2 or in prime.
2,
Uh, 3 in both.
3 in both.
Um, 5 in both. That's it.
6, what about 1?
Oh,
4.
1 and 4 and 6. Put it on the outside, like
1, 4, and 6 go here.
Oh wait, no.
Why doesn't
Four,
anybody go here?
four, four in grade and two.
Yeah.
Six in grade and two. And then one in grade and no, and then one on the outside.
What is outside exactly? So this is how we can set up the Venn diagram. Now, for example, if I want to know the probability of getting a prime number, what is it?
Um, 3 out of 6.
Exactly. If I want to know the probability of getting a prime number and one that is greater than 2,
Um, 4 out of 6.
prime and greater than 2,
Oh, 5 out of 6.
prime and greater than 2 together, intersection. Look at what I've written. I'm looking for the intersection, right? How many things do you see in the intersection of P and T?
Oh,
4?
two.
Two things, exactly. 3 and 5, that's it. 2 over 6, exactly. Um, what about, I want to know the P union T probability. How many things are there in P union T?
Uh, 5.
Answer would be 5 over 6.
Oh yeah,
Okay,
5 out of 6.
exactly. So, just a moment. Okay, so the next question is more of a slightly different one. So, as you can see over here, what do these numbers represent? They represent actual outcomes. Like 2 could be an outcome, 3 could be an outcome, 5 could be an outcome, right?
Mm-hmm.
Okay, let's try another question. Here, we instead have number of people. So 20 doesn't mean 20 is an outcome. 20 means that is the number of people in this region. 3 is the number of people in this region, and 7 blah blah blah. So read the question first, and then try to tell me what the answer to the first part will be.
Is is a
Mhm.
what? No wait. Numbers change.
How many people fit in this requirement? G intersection M.
3.
3 people. And how many people are there in total?
3.
How much?
38.
27, 30, 38. Exactly. So that's it. 3 out of 38. That's how many, like, that's the fraction of people who are studying G and M at the same time. You see?
Mm-hmm.
So that's it. So it's different from last time. Last time you were counting the number of things in the circle, but this time they've given you the count themselves. They could have written down the name of the people, like, name A, name B, name C, but instead they just wrote down that there's 3 people in this region. You see what I mean? You don't need to count
Yeah.
in this case. Last time you have to count 2 people here, so you did 2 over the total number of people, 6. But this time they just gave you the counts themselves. Okay, this is another case of Venn diagrams. Okay, now try to do the second part.
18 over 38.
15 over 8. So the probability of G complement. So how do you know that it's 18?
Wouldn't it be everything that's not in G?
Yeah. So how many things is that?
Oh wait, never mind. It'll be 15 over
Yeah,
38.
because exactly only 7 and 8. This is how many people are outside of G completely. 3 doesn't count because it's still in G, right?
Yeah.
So 7 and 8. So that's 15 over 38. Good. And finally, what's the probability of G union M?
30 over 38.
23 and 7 is 30. 30 over 38. Good job. So this is basically another way that you can get a Venn diagram problem. Okay. So now let's do a problem where we have to set up the Venn diagram ourselves, and hopefully I can find the type of question I'm looking for. Give me a second. Uh, okay. This is a kind of question you can expect in an exam also. Here. So they will give you a long statement, okay? And then they will expect you to create a Venn diagram yourself. So let's break this down first, okay? Read the question and then let's start creating the Venn diagram. Okay. So did you read the question?
Mm-hmm.
Okay. So you have 123 people, right? And they want to do a prom dinner. 75 choose a starter, 106 choose a main, 81 choose dessert, 67 choose main and dessert. It's easier to write this down when you make a Venn diagram directly, actually, so let's just do that. Now, how many circles should I have?
3.
Three. One for main, one for starter, and I should make it bigger. One for the starter, one for main, and one for your dessert. Okay, so this is starter, main, and dessert. Now, let's start. So, whenever you get a question like this is big advice. Always start with the most common part. Okay? So, start with this. How many people are choosing all three? Okay? Did they tell us? 67 chose a main course and dessert. 106 chose a main and dessert. What? 67 chose main and dessert. 64 chose starter and main. 49 chose starter and dessert. So everybody ordered at least one course. Find the probability that a chosen student randomly chose what? A student chosen at random chose all three courses. So they have not given us this. Okay? Let's call it X then for now. Okay? Because we don't know what this is. Right?
Mm-hmm.
We don't know how many people chose all three. So that's X. We don't know it. Now, we know that 67 people chose a main course and a dessert, which means that there are 67 people in this area. Right? Main and dessert. Is that clear?
Yeah.
So 67 in main and dessert, so there's 67. But that includes the X. So how many people are in just main and dessert? What do you think? 67 in this whole area, and this is X. So how much is in this then? Use basic
Si-
logic.
67 take away X.
Exactly. Good. Now, let's keep continuing. So we've covered this part. Let's tick it or something. Now, 64 chose a starter and main, which means that there's 64 people in this circle, in this area. So how many people are in this area?
64 take away X.
Good. And finally, 49 chose a starter and dessert, which is weird. Why would you eat a starter and dessert? So what would be here? 49 people are in total, so how much is here?
49 take away X.
Exactly. Good. Now, it says that 75 people chose a starter, which means that this complete circle contains 75 people, right?
Yeah.
So how many people just chose a starter? What do you think? So the number of people in the starter only, let's say. What is that? Because the total number of people in starter completely is 75, but that includes these three. I want to know just this part. How do I find it?
Would you add them and take that out away from
Yeah,
75?
exactly. So we can do 75 minus all of that added up, which leaves us with how much? 75 minus, what is 64 plus 49? It's 113.
113.
So 113 minus x, which leaves us with 75 minus 113, which is negative 38, and negative x is this. So we end up with this. This is the number of people in starter only, right? Is this clear so far?
Yes.
Okay. Let's do a similar exercise for mains. So 106 people did everything here, right? So the number of people in mains only would be 106 minus all of that. So 64 minus x plus 67 minus x. That totals to 106 minus 64 minus 67 is negative 25. The x's cancel out. This negative x and the minus outside makes it a plus, which makes it x minus 25. Okay?
Yeah.
And finally, 81 people chose dessert, which means that the part here will be, D only, would be 81, I think it's 81, yeah, minus 49 minus x plus 67 minus x. So I add all of these up and subtract them from 81, which gives me 81 minus 49 minus 67 is negative 32, so x minus 32. So this is x minus 32. So basically what we found out is that we know nothing. Right?
Yeah,
However,
basically.
there's one last thing that we haven't accounted for. We know the sum of all of this. It's 123.
Mm-hmm.
Isn't it? So all of this
Yeah.
should add up to 123. So let's write down our final statement, which will be that if I add up everything, x minus 38 plus 64 minus x minus 25 plus x plus 49 minus x plus 67 minus x plus x minus 32, all of this should add up to 123. So let's solve this now. We can cancel out all of the positive negative x's first, just to make life easier. And then let's add up all the numbers. We have minus 38 plus 64 minus 25 plus 49 plus 67 minus 32, which is 85. And what about the x's? We got one x here. That's actually it. Wow. X plus 85 equals 123, which means x is equal to 123 minus 85, which is 38. So 38 people chose all three things together. Okay, so you found that
Mm-hmm.
out. And then finally, we can find the probability of S intersection M intersection D, which basically means the intersection of all of them, which is basically the people that picked all three. Okay, which
Yeah.
is going to be what now?
38 over 123.
Exactly. I know that this was a long question, but I hope that you understand the method. It's always going to be the same. Start from the beginning. If you do not know the common part of all three of them, call it X, and then build outwards slowly. So look at this part, look at that part, look at that part, and then look at the whole circle, look at the whole circle, look at the whole circle. Okay?
Mm-hmm.
And this is it. Okay? This was a, by the way, one of the longer questions, of this kind of topic. You don't get normally this this long in an exam because obviously you don't have so much time. So let's now finally look at the next idea, which is conditional probability. This is a very important idea. Conditional probability is when something happens and then you want to find the probability of something else. Okay? It's very, like, it's impossible to understand what I just said until you look at it. So let me show you. A mathematics teacher sets two tests for 50 students. 40 pass the first test, 38 pass the second test, 30 people pass both tests. When you have these commonalities, it's always useful to draw a Venn diagram. So we have first test, let's call it 1, let's call it F, and let's call the second test S, because then it would be annoying if we had numbers as the name of our sets. Second test. And this is the universal set. So we got 50 students, so everything should add up to 50 at the end. We start from the innermost part. What do I put here?
Uh, 30.
30, because 30 people passed both tests. Since 40 people passed the first test only, right? No, not only. 40 people passed the first test, so what should I put here then? Should I put
Uh,
40 here?
yeah.
No, they're not saying that's they only passed the first test. This includes the people that passed the second test also.
Oh, okay.
So what should I put here?
Would you um
Look, if 40 people passed the first test and 30 people out of those 40 people passed the second test
you put
also.
10, yeah.
Yeah, exactly. 40 minus 30. What about here?
You would put 38 past it. You put 8.
Exactly. Is there anybody who comes outside of FNS?
Yeah.
How much? How many people?
2.
Two. Because this accounts for only 48 people. There's 50 students in the class. So there were two kids who failed both tests. Perfect. The first question is, what's the probability that a person selected at random has passed both tests? First of all, how do I write this down as set notation?
F and then what's
Union or
that?
intersection?
Intersection.
Yeah. What is it?
30 over 50.
Exactly. Now here's the fun part. The second question says, passed the second test, given that the student has passed the first test. So what's happening here is, when you see a given that, what you're saying is that you have a classroom of 50 people, right? When you say given that the student has passed the first test, what you're essentially doing is you're not asking all of the students now. You tell all the students, only the people who passed the first test should step forward. Okay? So how many people would step forward?
Um,
If I have this condition, see, given that implies that this is the condition, okay? So how many people will fulfill this condition?
a second test again. So they passed both
No,
tests.
no, forget about this for now. I'm only asking you, this is the condition. This is what I'm announcing to the class. Only the people who passed the first test should step forward. How many people would step forward in that case? If I ask
40.
that? 40 people, exactly. Because the circle of first test students contains 40 people in total. But some of these guys also passed the second test. You see?
Yeah.
So, what's the probability that watch carefully, okay? I'm writing down the notation. This is extremely important. What's the probability that you pass the second test given that you have passed the first test? This part is me saying I am only looking at the people that passed the first test. Okay? So I'm not looking at the full Venn diagram anymore. I'm only looking at this part of the Venn diagram. Okay? I don't care about the 50 people. I only care about the 40 people. So what's the probability that you have passed the second test given that you have passed the first test? So how many people out of this whole thing passed the second test?
30.
And how many people am I talking about in total?
40.
Exactly. Not 50, but 40. So the probability is 3 over 4. So passing the second test, if I'm only asking the people who've passed the first test, is 3 over 4. Okay? Do you understand this?
Yeah.
Okay. There is a formula for conditional probability, but I'm not sure if you're supposed to know about that yet. Let me see. Okay, now you're not supposed to know about it yet. So let's look at a question now. Okay, so in this question, we have the Venn diagram given to us. It's the number of people in different sets, blah, blah, blah. Same old deal. First question is how many people chose all three fillings? I mean, what's the answer to the first one? Go on.
12 out of.
No, no, it's just how many. It's not asking you for probability.
Oh,
Yeah, so you can say number of people. How do I write this down as a set notation? People that chose all three fillings.
um,
How?
the intersection
Of what?
of C, T, and E.
Exactly. So I will say C intersection T intersection E, won't I?
Oh, okay.
This is 12. Okay, perfect. Now, first probability that you need to find is the intersection of T and E. So what is it? Probability, by the way. The total
Mm,
number of people, by the way, you need that too. Just remember. Anyways, what's the probability of T and E? T intersection E.
23 over.
That's only the people that are only T and E. We don't. I never said that. Don't consider these guys. They're also T and E. They're also C, but we don't care. T and E contains 23 and 12 both. That's T and E, isn't it?
Yeah.
Yeah. So 12 plus 23. That's how many people are in T and E. Divided by how many people? How are you gonna find it, by the way?
Just add them.
Exactly.
Those 23 plus 1.
70 people, that is.
70.
Uh-huh. So 35 over 70. What is that?
Um, 5 over 10.
1 over
1 over
2.
2.
Right. Okay, good. So what's the probability of C? Okay, this is easy. It's just gonna be 12 over 70, right? Intersection of all of them is 12, 12 over 70. The third part is where I wanted to really get at. The probability
Mhm.
of, how do I say this? What does this mean?
Um, the like oh my days, the whole of E.
No. C is the condition. E, given that I'm only talking about the C people. The condition is this part, and this is whose probability I'm trying to find. So which circle
Oh,
should I draw?
C.
Okay, let's draw C. We don't need to draw it, we can just look.
Yeah.
This is C, okay? So how many people are in C?
38.
And how many people account for E that are in C?
27.
Exactly. That's your answer. So it's simple as that. This is the part of E given that it is in C already. Okay? So basically
Oh,
the this like makes your what's the word? Shrinks your universal set. You're not talking about the full Venn diagram anymore. You're only talking about the C part. Okay? That's all you need to know. The only new thing about Venn diagrams. About conditional probability, okay?
okay.
Perfect.